we have a train car that's moving to the right with an initial speed v1. It collides with a stationary train car of equal mass. After the collision, the two cars are stuck together. What is the train car's final velocity? In this situation, we have a collision. We have the one train car that rolls in and collides with the other one. And we see that this is a perfectly inelastic collision because the two not only collide with each other, but they collide and they stick together. And when we deal with collisions like this, we have to consider them from the perspective of momentum. So if we want to look at the conservation of momentum, since momentum is conserved in a perfectly inelastic collision, we have to consider the momentum before the collision and the momentum after the collision. The momentum before the collision is the total momentum of all of the objects before the collision. So we have our two train cars, and each one has momentum. However, the second train car is not moving, and so in that case, its momentum is 0. The momentum of the first car is the mass, which we'll call sum m, since both have the same mass, times its velocity, v1, and it's moving to the right, so we don't have to deal with that in any way. Basically, we'll assume that v1 is positive, and we're moving to the right, so the momentum should be positive. When we look at the final momentum, although it's technically two train cars that are rolling together, at this point they're acting as one object. And so there's really only one object to consider. And you have a momentum of that one object, which will be the mass of the total object multiplied by the velocity. And we use a stylized v here just to distinguish from the initial velocity. What we can say then, since momentum is conserved, the initial velocity initial momentum has to equal the final momentum, and thus the initial momentum must equal the final momentum, where here we've taken the m1 plus m2 and we've made it a 2m. We've just simplified that. We also notice that we have a common factor of m that we can cancel out, and thus we can see that the initial velocity is 2 times the final velocity, or we can say that the final velocity after the collision is the initial velocity divided by 2. That's what we get from the conservation of momentum. What we can look at as well, if we want to look at the change in kinetic energy, we can say the kinetic energy before the collision was 1/2 mv1 squared, because that was the mass of object 1, it was moving with a velocity v, and technically there's a plus 0 from the second car that's not moving, and thus had no kinetic energy. The kinetic energy at the end, we have one object that's moving. It has a mass of 2m. It's moving with a velocity v. We can cancel our 2's. We see here, looking at our kinetic energies, that the kinetic energy at the end you have twice the mass that's moving, but that mass is moving half as fast, which becomes a factor of a quarter. And so in fact, after the collision, you have half the kinetic energy that you had at the beginning. That's what we meant when we said that you have kinetic energy loss in a perfectly inelastic collision.